Hello, everybody. I'm Butch Stearns of the Pulse Network, and we welcome you in once again to Necconnect. Necconnect is a monthly webisode that brings you everything you need to know around the National Electrical Code. And it's a webisode that's tied to a bigger community at necconnect.org, which is your go-to source for electrical safety, for everything to do with the National Electrical Code. Again, my name is Butch Stearns, and for today's episode, we bring in a familiar face. Chris Coache, Senior Electrical Engineer for the NFPA. Hi, Chris.
Hi, Butch.
How you doing?
Well, glad to be back.
Yeah, glad to have you here. You love this stuff. You are passionate about
I'm
this.
going to have to join the Screen Actors Guild.
And for a lot of good reasons. I like the subject of today's show because everybody in the audience out there who makes their living around electrical safety and around the National Electrical Code, to me, this is one of those that might be taken for granted, and we want to reinforce some things here today, right?
Yeah. Today's topic, mostly basically on Ampacity, people just take things for granted. They go to the code, they use it, but they don't read or fully understand what the requirements are. So it'll be an interesting discussion.
So today's discussion is ampacity and why temperature is critical to understanding wiring methods and materials. Now, on one hand, you might be out there saying, well, duh, temperature is critical. But again, in the vein of taking things for granted or reinforcing some things, let's go right back to the beginning, Chris.
Yeah.
The term ampacity, where did it come from and what does it mean?
Well, the term ampacity was actually coined by the National Electrical Code, I don't remember how many years ago, well before my time. Ampacity is the maximum current in amperes that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. So it's really a temperature, even though it's based in amperage, it's a temperature requirement.
Thus, the subject of what we're talking about,
Yep.
how temperature ties into this.
Right.
So hammer that a little bit more. So your ampacity, your rating, can be the load of what can be carried, yet the temperature outside is what affects this, right?
Well, there's lots of things called the conditions of use that we'll get to a little bit later. But for example, just to show you how, if you look at table 310.15b16, if you have a 250 kc mil conductor, so that's the actual dimension of the copper that's going to be carrying the current.
Okay.
That has a ampacity of 215 amps if it's a 60-degree insulation. That same conductor, if you put it in 90-degree insulation, has a current carrying capacity of 290 amps. So it's really temperature-based, not current-based.
And again, when you point to this particular table, and these tables in general, this one 310.15b16, your point, there's rows and there's columns,
Yeah.
and there's different ones. What are some of the common mistakes people make? They don't look it through, they don't read it thoroughly.
They don't look through the right columns. There's one column for aluminum conductors, one column, or I should say one set for aluminum conductors, one set for copper conductors. There's different temperature ratings of the insulation. There's the type of insulation that's used, so you need to look at the whole thing. And again, so ampacity, it's not 250 kc mil conductor at 90 degrees, 290 amps through that is not the maximum that it can carry. It's the maximum it can carry, not exceed that rating. A 250 kc mil conductor can carry a lot more current than 290 amps. So again, it's really ampacity is temperature based.
All right, let's talk about conditions of use, because part of the joy and what's valuable about the National Electrical Code is ideally you cover almost any situation that happens. And when we're talking about ampacity here, you want to avoid short circuits, ground faults, arcing, and all those type of things. So what's important to remember about conditions of use?
Well, conditions of use are things that don't exist in that table. The table has certain conditions that it's made an assumption on, that you have 3 current carrying conductors, for example, or it's 30 degrees C, or it's buried in earth. Any of conditions of use other than that, you need to take adjustments into account or corrections into account. And the temperature of the conductor, the 90 degree C insulation or 60 degree insulation, that's the temperature over the entire run of the conductor. So when you take everything into account, the conditions of use, you need to look over your entire length of your conductor, not just this short section here or this long section there. It's everywhere from the termination to terminations.